So now we're going to be going over Lab 7 Circular Motion Part 2. The items that we're going to need for this are our safety goggles, our circular motion apparatus, a meter stick, a timer, and a protractor. So David, how do we run this experiment?
Well, first we want to make sure this is the little mass that's mentioned, and this is the capital M, the big mass. So we want to weigh these two masses, put on your safety goggles, and what we're going to do now is more quantitative compared to the last video, the qualitative, the ball and string. I'm going to whip this guy around in a circle. And the circle I want to whip around, I want to be fast enough so that that string, when it's in contact, making the least amount of contact, the least amount of friction with the rim as possible. Because friction is not in our analysis, so the faster this guy goes, the less it's in contact. I mean, if it goes real slow, you can see that that handle is holding up the string more so than we whip around fast. So we want to get that fast as possible to get rid of that error by ignoring the friction. So now we're going to go around quite quickly, and one of your group mates is going to measure, just by an estimate, what roughly the angle looks like between the string, from the top of the string to the stopper. Meaning, notice the top of the string, where my thumb is higher than where the stopper is going. So this stopper should go in a plane, a horizontal plane parallel to the floor. And so it's angled, as you see in the illustration in the text. Somebody else in your group will roughly measure the diameter of the circle that it's going around. So you want this guy to go around nice and fast, have the diameter circle. Half the diameter is the radius of that circle, and you're also going to measure the total length of the string before you start doing this, and then you can measure the length of the string that's hanging. Knowing the total length and the length of the string that's hanging can give you the length of the string that's being whipped around, which is the hypotenuse of a right triangle. If we were to say, look at a moment of time, we can estimate the angle by SOHCAHTOA, knowing the radius, having that measured, and the length of this string that's being whipped around, the hypotenuse, we can measure using SOHCAHTOA the angle, and that should be pretty close to our estimate from the protractor. As it's going around, somebody in your group is going to time how long it takes to go around, and it goes around so quickly that you're not going to try to time it for each revolution. Each period of time is too quick. So instead, count your favorite number, 7, 11, 13, and then time how long it takes to go around 7, 11, or 13 times, and divide it by that number, and that would be your average period of time for this. And with that is all you need to do this lab.